Welcome to the Deep Dive. Today we're tackling something pretty fundamental to how software gets made these days. CI/CD.
Right. Continuous integration and continuous deployment.
Exactly. If you've ever, wondered how apps update so smoothly, almost constantly, or how companies push out features basically overnight, well, this is kind of the magic behind it.
It seems like magic sometimes.
It really does. So we've dug into a whole bunch of sources, articles, expert takes to really break down this whole automation thing.
Yeah, and our goal here really is to cut through the buzzwords. Let's get to what CI/CD actually is, how it works, and why it's such a big deal for development teams.
And the challenges too, right? It's not always easy.
Definitely not. We'll cover the hurdles and the best ways around them. It's all about making software development faster, yeah, but also more reliable, much more reliable.
Okay, let's unpack that. So the big picture, CI/CD is basically automating the code's journey from a developer's laptop right into the hands of users.
Pretty much, yeah. It takes the code from commit all the way through testing and then out to production.
Which is so different from how things used to be done. I remember hearing about these nightmare Big Bang releases,
Yeah.
months of work, then this huge, stressful manual handoff.
Oh, totally. Fraught with peril.
Yeah.
CI/CD streamlines that whole life cycle. It enforces frequent small changes, automated builds, automated tests, delivery. It's a constant flow, not those massive risky drops.
Constant, small, iterative. That sounds way less stressful.
It is.
I saw Martin Fowler mention that the key is developers merging to the main code base, like daily, and getting automated feedback straight away. He said it reduces the risk of delivery delays. How does that daily check-in help so much?
It's absolutely critical. Think of it like catching a typo when you write one sentence versus finding it after you've written a whole chapter.
Oh, okay.
If you merge code daily and automated tests run immediately, any conflicts or bugs are tiny. They're found right when they're introduced. You fix it in minutes.
Instead of weeks later when it's tangled up with everyone else's changes?
Exactly. It keeps the code base stable and stops small issues from snowballing into, complete chaos. Saves a ton of time and, frankly, developer sanity.
Right. So, with that sort of philosophy in mind,
Hmm.
where does this automation journey actually begin? Continuous integration, CI, that's the first piece, yeah.
That's the foundation. Absolutely.
What does that look like for a developer day to day?
Okay, so in a typical CI setup,
Yeah.
developers are committing code frequently, small chunks,
Mm.
maybe multiple times a day even.
Into a central place like Git.
Yep, into a shared repository using version control like Git.
Mm-hmm.
And here's the key. Every time they push that code or merge it,
Mm-hmm.
it triggers an automatic process.
Ah, the automation kicks in.
Right. A CI server could be Jenkins, GitLab CI, GitHub Actions, lots of options, grabs that new code, it compiles it, builds it, and then runs a whole battery of automated tests.
What kind of tests?
Usually starts with unit tests, checking small pieces of code work correctly on their own. Then maybe static analysis, checking for code style issues or potential bugs without even running it.
So you get that feedback loop almost instantly if something's wrong.
That's the goal. If a new commit breaks something, maybe a test fails. The CI system flags it immediately. The whole team sees it.
Okay, so it's not just about catching bugs earlier, though that's obviously huge.
Mm.
Does it help with that old integration anxiety, that fear of merging your work?
Oh, massively. It
Right.
changes the whole psychology. Developers trust the process more because they know their small change gets validated right away. It's less, oh God, what if I break everything?
Yeah.
And more, okay, let's see if this passes.
That sounds much healthier.
It really is. And it removes huge bottlenecks. Think about that merge day horror story.
Right, weeks or months of work all crashing together at the end.
Exactly. I've heard stories, big projects, where integrating different parts literally took months. With CI, integration isn't a phase at the end. It's happening constantly, in minutes or hours for each small change.
Wow. So does this almost force developers into better habits, like making smaller, more focused commits because they know it's going to be tested right away?
It strongly encourages it, yeah. You want small commits because they're easier to test, easier to understand, and easier to fix if they break something. Atlassian points out, developers doing CI well merge their changes back to the main branch as often as possible. It just becomes the natural workflow.
Makes sense. You mentioned unit tests and static analysis. What else goes into a really solid CI check?
A really robust CI process will usually include integration tests too, making sure different parts of the system work together correctly.
Okay.
It might check code coverage, like how much your code is actually being tested. And increasingly, security vulnerability scanning is built right in.
Security scans too,
Yeah,
early on.
yeah, finding security issues early is way cheaper and safer than finding them in production. So these steps act like quality gates. If anything fails, the process stops.
And this whole process, the pipeline itself, you mentioned defining it as code, like a Jenkins file or a .gitlab-ci.iml. What's the advantage there?
Pipeline as code. It's huge.
Uh-huh.
Basically, you write down all the steps, compile, test, scan, whatever, in a configuration file that lives right alongside your application code in version control.
So the pipeline itself is version.
Exactly. It means the build and test process is repeatable, consistent, and transparent. Anyone can see how it works, and changes to the pipeline are tracked and reviewed just like any other code change. No more mystery build server configurations.
Got it. So summing up CI, it creates this low-risk, constantly verified, transparent way of working. Everyone sees the build status. Everyone feels ownership of keeping it green. It really sounds like it boosts collaboration.
It absolutely does.
Yeah.
The team owns the code base health together.
Okay, so CI gets the code integrated and tested frequently. What about getting it out the door? That's where CD comes in. Continuous delivery and continuous deployment. Can you clear up the difference? Because that CD abbreviation trips people up.
Yeah, it definitely can. They sound similar, but the difference is crucial. Let's start with continuous delivery. With continuous delivery, every change that passes CI is automatically built, tested, and packaged up, so it's ready to be deployed to production. It produces an artifact, like a runnable version of your app.
Ready, but not necessarily deployed automatically.
Exactly. The key is the final step, the actual push to production, is still triggered manually. Maybe by a product manager, maybe after some final checks. Atlassian says the code is always maintained in a state where it's ready for deployment, but the actual deployment is triggered manually. So you could deploy anytime, maybe multiple times a day, but a human pushes the button.
Got it. Ready to go, manual trigger. So what's continuous deployment then?
Continuous deployment takes it one step further. It removes that manual trigger.
Ah,
If a change passes all the automated tests in the entire pipeline CI, integration tests, maybe even tests in a staging environment, it gets deployed automatically to production. No human intervention needed for the release itself,
wow. Okay.
like Atlassian puts it. Every change that passes all stages of your production pipeline is released to your customers, straight through.
That sounds incredibly fast. If every good change goes live automatically, your work could be in front of users in minutes.
Potentially, yeah. Minutes or hours after you commit the code.
What does that do for a business? Or for user feedback?
It creates this super tight feedback loop.
Mm.
You can get new ideas or fixes out instantly, see how users react, and iterate incredibly quickly. It allows for constant low-risk experiments.
Changes how you even think about releases, I guess.
Totally. It eliminates release day stress.
Mhm.
Software becomes less of a big product launch and more of a continuous service. It's always evolving.
That sounds risky too, if there's no human gatekeeper.
Exactly. And that's the big prerequisite. Continuous deployment needs incredibly high confidence in your automated testing. Red Hat notes it relies heavily on well-designed test automation.
You have to really trust those tests.
You absolutely do. It requires a serious investment upfront in building comprehensive, reliable test suites, plus good monitoring and rollback plans, because things can still go wrong.
So that's why maybe not everyone jumps straight to full continuous deployment. They might stick with continuous delivery.
Precisely. Many organizations use continuous delivery, always ready, deploy on demand, because it gives them that final control point. It often depends on the application, the team's maturity, risk tolerance, sometimes even regulations.
Makes sense. But either way, the CI/CD pipeline is the engine driving it all. You mentioned quality gates earlier. How do those work stage by stage?
Right. Think of the pipeline as a series of stages, each one a gate. First stage, compile the code. Does it even build? Gate passed.
Okay.
Next stage, run unit tests. Do the individual pieces work? Gate passed. Then maybe integration tests. Do the pieces work together? Pass. Security scan. Pass. Maybe deploy to a staging environment and run some end-to-end tests. Pass.
And if any gate fails?
The pipeline stops.
Yeah.
Immediately. It doesn't proceed. And it tells you exactly which gate failed. Fail fast, fix fast.
And that whole pipeline structure, just like the CI part, is defined as code, too.
Ideally, yes. That pipeline as code principle applies to the whole thing, from commit to potentially production. Usually in those YAML files are similar.
Why is that so important for the whole CD process?
Consistency, again, but also reproducibility. You know exactly how every release was built and deployed. And auditability, you have a record in version control of your entire release process. Makes troubleshooting, sharing, and improving the process way easier.
Okay, we've covered the what and the how. Let's talk impact. What does adopting CI/CD really mean for an organization? What are the big transformative benefits?
Well, the first one is obvious, but huge. Faster, more reliable releases. Automation just slashes the time it takes to get code out.
Fewer manual steps mean fewer human errors.
Exactly. GitLab says it dramatically reduces the time and risk. Red Hat points out it minimizes downtime. You're pushing small changes frequently, which are inherently less risky than massive updates. You can react to market needs or user feedback almost instantly.
So speed and reliability. What else?
Collaboration and transparency get a massive boost. When everyone can see the build status, see the test results, maybe on a dashboard.
Everyone's on the same page.
Right. Bottlenecks become obvious. GitLab calls it fostering a culture of collaboration and transparency. It reduces cognitive load. Developers focus on code, not complex deployment Ganses. That generally makes for happier, more productive developers.
Happier developers are usually a good sign.
Definitely. Third big benefit, predictability and lower risk. Because every single deployment follows the exact same automated process, releases become routine, not terrifying events.
Fewer surprises.
Way fewer surprises. Atlassian notes, left bugs get shipped because the automated tests catch regressions early. And if a bug does slip through, the change was small, so finding and fixing the problem is much, much faster.
Okay, that makes sense. Any other major wins?
Yeah, cost savings and scalability, often. While there's an upfront investment in setting up pipelines and tests, the time saved on manual work adds up significantly.
Pays off in the long run.
Usually, yes. Plus, as Atlassian mentions, good CI/CD helps decouple teams. Different teams can work on different features and release independently without stepping on each other's toes as much. That helps organizations scale their development efforts without getting bogged down. Better quality, faster releases. That usually translates to happier customers and better business outcomes.
Okay, it sounds incredibly powerful. But you hinted earlier, it's not always a walk in the park. What are the real challenges teams face when trying to adopt CI/CD?
Yeah, it's definitely not frictionless. The initial setup, for one, can be daunting, especially for organizations new to this kind of automation.
Just picking the tools and getting started.
Picking tools, integrating them, maybe changing existing workflows, and the cultural shift, getting developers comfortable with frequent merges, writing good tests. That takes time and effort. Training is often needed.
Okay, setup and culture. What else?
Yeah. Maintaining the quality and speed of your tests is a constant battle. The whole pipeline relies on good tests. If your tests are slow, they kill that fast feedback loop. If they're flaky, sometimes passing, sometimes failing, for no clear reason, people lose trust in the pipeline.
Right, if the light's always red, you start ignoring it.
Exactly. Atlassian warns that any delay will compound as the team grows. You can accumulate test debt code without good tests, which undermines the whole point.
Aren't there technical challenges too, like managing different environments?
Oh yeah, integration problems still happen. Merge conflicts, builds that break unexpectedly, managing dependencies. And a big one is environment parity.
Making sure development, testing, and production look the same.
Precisely. If they drift apart, code might work fine in the CI environment, but then break when it hits production. BrowserStack highlights this pain point. Things like containers, Docker, and infrastructure as code Terraform help a lot here, making environments more consistent.
But they add their own complexity.
They do. They're powerful tools, but there's a learning curve there too.
And specifically for continuous deployment, that highest level of automation, what's the big hurdle there?
Trust. Pure and simple. Since there's no final human check before production, you need, as Red Hat emphasizes, that extreme confidence in your test automation. It demands rigorous processes, comprehensive tests, really solid monitoring to catch issues immediately, and fast rollback capabilities. Because things will slip through occasionally, and you need to react instantly.
Okay, so there are definitely hurdles. Given those, how do teams actually succeed? What are the best practices that really make CI/CD work well?
Well, number one, echoing what we said earlier,
Yeah.
commit and integrate frequently. Small changes merge often, ideally daily or more.
Keep the changes small and manageable.
Exactly. It makes everything downstream easier, faster builds, simpler debugging, and incorporate code reviews like pull requests as part of that process. Atlassian notes that's a great point to trigger CI checks too.
Makes sense. What's next?
Automated testing is non-negotiable. It's the foundation. Tests need to be fast, reliable, and cover the important parts of your code.
High coverage.
Good coverage, yeah. Things like test-driven development, where you write tests first, can really help build that solid testing culture and keep those test environments consistent with production use containers, as Red Hat suggests, to avoid environment drift.
Okay, frequent commits, solid tests. What else?
Optimize the pipeline speed. Seriously, this is crucial. If developers commit multiple times a day, a pipeline that takes an hour is a major drag.
Kills the fast feedback.
Totally. So measure build times, look for bottlenecks. Can you cache dependencies? Can you run tests in parallel? Atlassian says a faster CI pipeline enables a faster product feedback loop. It keeps developers productive and happy.
Treat the pipeline itself like a product you need to improve.
Absolutely.
Yeah.
And related to that, treat infrastructure and pipeline definitions as code. Keep those YAML files, Jenkins files, Terraform, scripts, whatever, in version control.
Review them, test them.
Yes, just like application code. It ensures repeatability, consistency, and makes managing environments so much easier.
Okay, one more.
Plan for reliability and recovery. Things sometimes go wrong even with the best pipelines. So use techniques like feature flags, letting you turn features on or off in production without deploying code.
Oh.
Or blue-green deployments, having two identical production environments and switching traffic once the new one is verified. Have good monitoring and alerts. And integrate security early, shift left, they call it. Scan for vulnerabilities as part of the pipeline. Don't wait until the end. That's DevSecOps, basically.
Right, building security in from the start. Okay, this whole ecosystem clearly relies on a lot of tools working together. To kind of wrap this part up, what are some of the key players, the common tools people use?
Sure. For the CI part, the build and test automation, you've got the classic, Jenkins. Very powerful, very customizable, self-hosted.
The workhorse.
Kinda, yeah.
Yeah.
But then there are tons of popular cloud-based or integrated options. GitLab CI/CD is built into GitLab. GitHub Actions is built into GitHub. Circle CI, Travis CI are popular standalone services. Azure has DevOps pipelines. AWS has Code Pipeline. Atlassian has Bitbucket pipelines and Bamboo. Lots of choices depending on your stack.
And for the CD part, the delivery and deployment orchestration.
There you see tools maybe more focused on complex release strategies. Netflix open source Spinnaker, which is powerful for multi-cloud deployments. In the Kubernetes world, you see tools like Tecton pipelines for defining pipelines natively in K8s, and Argo CD or Flux for GitOps-style continuous delivery where your Git repo defines the desired state of your cluster.
So tools specifically for managing those complex releases to production.
Exactly. Managing different environments, handling rollbacks, progressive delivery like Canary releases, that's their specialty.
And you mentioned supporting tech too, like Docker and Kubernetes.
Yeah, they're not strictly CI/CD tools themselves, but they're almost essential building blocks now. Pipelines very often build Docker container images. And then they use orchestration platforms like Kubernetes to actually deploy and run those containers. Configuration management tools like Ansible or Chef, and infrastructure as code tools like Terraform are also frequently invoked by the pipeline to set up or manage the environments the code runs in. They're all part of that automated tool chain.
So it's really about weaving all these pieces together: version control, build tools, testing frameworks, deployment scripts, automating that entire chain.
That's the goal, yeah. Automate as much as humanly possible, from the moment code is committed right through to it running reliably in production, making the whole process visible and trustworthy.
We've really covered a lot of ground there. So CI/CD. It's clearly way more than just buzzwords. It feels like a fundamental shift in how software is built and delivered, focusing on speed, reliability, and collaboration.
Absolutely. It's become a critical practice for any modern software team wanting to move fast and stay stable. So maybe a final thought for you to chew on. Now that you have a clearer picture of this level of automation, how does it change how you think about software development itself and beyond just tech? What kinds of possibilities does this kind of rapid, reliable delivery open up for innovation, for responding to user needs in almost any field you can imagine? If you enjoyed this video and found it helpful, don't forget to like, comment, and share it, with others who might benefit too. To learn more about product management and digital marketing, make sure to subscribe and hit the bell icon so you never miss an update.